Hey, this is Brock Grell with Modus Labs. I'm going to be talking about how Modus Labs determines life. So this is a gearbox technology, just an example of one of the ones that Modus Labs will be coming out with. And when it comes to gearboxes, we really need to understand how long are they going to last and under what conditions. So that way a customer can design that into their design and know when are they going to need to replace it or when is it going to start degrading, if there's any re-greasing options, those types of things. So understanding life is very important, and being able to consistently achieve that is also very important. So one of the things that Modus does in general is tries to find and validate the failure mode. So in this specific gearbox, our failure mode today is the flexure. So the compliance flexure is inside the gearbox. It is taking the most load. It's not a bearing failure at this time. We do believe it's going to be the flexure. So we have a separate test that is specifically testing the flexure and validating it in a more accelerated way than being able to run it on Striker. And we will be going through that test bench and that type of testing cycle on a different video. So coming back to life on how we're testing life today is once we understand that accelerated testing and we validated that that part is most likely going to be the failure mode, we get to hook the unit up and set it up to its parameters and our specifications and duty cycle it. So like for this example on this unit, we're taking it from a little bit lower than average speed all the way up to max speed and fluctuating in that range. And we're taking it from average torque all the way up to maximum torque and fluctuating in that range. And we're also changing directions. And we have that kind of calculated out to what's going to give us the best bang for our buck in terms of time. And so we're able to run that and understand exactly what's going on in the system using both the input encoder, the output encoder, the input torque transducer, this FUTEC, and the output torque transducer. So throughout the process, we can stop, do the parametric testing, and validate that nothing major has changed. Are we losing accuracy? Are we gaining backlash? Is efficiency changing? And we can do that every so often, and how often that is depends on what we come up with from engineering. There's a lot of pieces to that part, but that's a separate issue. And so you can see it right now doing some of that preliminary testing to just validate the values and the numbers, and then when it goes through duty cycle testing, we kind of get out of the room because we want it to be able to do its thing. And we also have some vibration sensors up there, which allow us to see if it's getting noisier, if it's shaking more, if bad things are happening on the inside when we're duty cycling it. And we also have a thermal sensor, a couple different options for thermal sensors to see, is it getting hotter or is it getting cooler? Because backlash is going up and efficiency is getting better from that type of a situation, is the unit cooling off? So there's just all these different variables that we get to see with this test stand all in one setup, which is really great.